Hello everyone, welcome to Fun with Learning. Today we'll solve exercise 7.3 of chapter Integration. Today we'll cover all the questions of this exercise and we'll see certain more methods of particular question. Before that, we need to know certain trigonometric identities that I'm telling you here that we'll be using in particular questions. So first identity we have 1 plus cos 2 theta equal to 2 cos square x, and second identity is 1 minus cos 2 theta equal is 2 sin square x. We'll use this identity to integrate this type of integration consisting of cos square x and sin square x. Second is sin 3x equal to 3 sin x minus 4 sin cube x. And then fourth is cos 3 theta equal to 4 cos cube x minus 3 cos x. So we'll use this two identity to integrate integration consisting of sin cube x or cos cube x. Fifth identity is sin square x plus cos square x equal to 1. We'll replace 1 with this sin square x plus cos square x. And we'll see some trigonometric identities like this 2 sin a cos b, 2 cos a sin b, 2 sin a sin b, 2 cos a cos b. You can see the formula of this thing in your copy or book. I will mention this in question. So first question we have integration of sin square 2x plus 5. Here we'll be using trigonometric identities 1 minus cos 2x equal to 2 sin square x. So I'll write here 2 sin square theta equal to 1 minus cos 2 theta. This will imply sin square 2x plus 5 equal to 1 minus cos 2, and our theta is 2x plus 5. So it will be upon 2. So now I can replace sin square 2x plus 5 by 1 minus cos 2 into 2x plus 5 upon 2. So I will have integration 1 minus cos 2 into 2x plus 5 upon 2 dx. I can send this constant outside. So I'll be left with 1 minus cos 4x plus 10 dx. I can separate into two integration. So I'll get 1 by 2 into integration dx minus 1 by 2 into integration of cos 4x plus 10 dx. Integration of constant will be x, and then integration of cos will be sin, because the differentiation of sin is cos. So we'll write sin 4x plus 10. Again, we know that integration of cos x is sin x, but here cos 4x plus 10 is there. So here we can apply a substitution method to solve this thing, or directly what we can do, we can differentiate 4x plus 10, we'll get 4. Since it is integration, we'll divide by 4 and then we'll write c, because it is indefinite integration. So we're left with x upon 2 minus 1 by 8 sine 4x plus 10 plus c, answer. You can see answer this first question, x by 2 minus 1 by 8. Okay, it's right. So we're moving on to next question. Second question is integration sin 3x into cos 4x. Here we can apply 2 sin a into cos b formula. The formula of 2 sin a cos b is sin a plus b plus sin a minus b. So what we can To apply this formula, I will multiply 1 by 2 outside and I will take 2 into inside. 2 sin 3x into cos 4x dx. So now once I apply this formula, I will get sin 7x plus sin 3x minus 4x dx. And we know that sin minus theta is equal to minus sin theta. So here, now I'll separate these two function into two different integration. I will get integration 1 by 2 sin 7x plus 1 by 2 integration sin 3x minus 4, it will be sin minus x dx. 1 by 2 integration of sin 7x minus 1 by 2 integration sin x dx, because sin minus theta equal to minus sin theta. And we know that differentiation of cos theta is minus sin theta. So I need to multiply minus outside and minus inside. So integration of minus sin 7x will be cos 7x. But 7 is there in multiplication with x. So once I will differentiate this 7x, I will get 7 as out in outside. So I'll divide by 7 in denominator. So now 1 by 2, I'm taking this minus inside. Since the differentiation of cos x is minus sin x, cos x is equal to minus sin x. So the integration of minus sin x will be cos x. So our answer should be minus 1 upon 14 cos 7x plus 1 by 2 cos x plus c, answer. So second number is 1 minus 1 upon 40 cos 7x plus 1 by 2 cos x. So it's fine. Now we are moving on to third question. These two questions are almost same, but here we'll apply 2 cos A cos B formula. So the formula of 2 cos A and 2 cos B is cos A plus B plus cos A minus B. Here we can apply this formula on anything, like here we can apply this formula for these two function together at first, or we can choose these two function at first, or we can choose these two function together. There will be no problem. So I'm choosing these two things together. So for that I'll multiply 1 by 2 outside and I'll take 2 inside. 2 cos 2x cos 4x into cos 6x. So here it will be 1 by 2 into 2. The formula of 2 cos A cos B is cos A plus B. Cos A plus B plus cos A minus B. And into cos 6x is there. Here we know that cos minus x is minus sin x, since cos minus x is cos x. In fourth quadrant, cos is positive. Cos x is positive. So that's why we can write 1 by 2 into integration cos 6x plus cos 2x into cos 6x dx. So here we'll left with 1 by 2 into cos square 6x plus cos 2x into cos 6x. One by 2 into cos square 6x dx plus 1 by 2 into cos 2x into cos 6x. This integration we can solve by formula of 1 plus cos 2 theta equal to 2 cos square theta. So here you can write 1 plus, because I need 6 in square as theta. So I'll write cos 12 theta equal to 2 cos square 6 theta. And here we can apply the formula of 2 cos A into cos B. So you can solve this question by these two trigonometric identities. So now we are moving on to next question. This was third and this is fourth number. Here we can apply a trigonometric identity consisting of sine cube x. Sine 3 theta was equal to 3 sine theta minus 4 sine cube theta. So 4 sine cube theta will be 3 sine theta minus sine 3 theta. Implies we can write integration of sine cube 2x plus 1 will be 3 sine 2x plus 1 minus sine 3 into 2x plus 1 by 4 dx. So now we can separate. I am sending 1 by 4 outside at first. So we'll left with 3 sine 2x plus 1 minus sine 3 into 2x plus 1 dx. Now I can separate them into two integration. So 3 upon 4 integration sine 2x plus 1 dx minus 1 upon 4 integration sine 6x plus 3 dx. Again we'll be using as the differentiation of cos x is minus sine x. So integration of minus sine x will be cos 2x plus 1, but 2 is there in multiplication with x, so we'll divide by 2. So now 1 upon 4, again I'm taking this minus inside. So integration of minus sine x will be cos 6x plus 3, cos 6x plus 3, and 6 was in multiplication, so 6 will divide cos by 6 plus c answer. So now we'll have minus 3 upon 8 cos 2x plus 1 plus 1 by 24 cos 6x plus 3 plus c answer. So now we can check. This was fourth number. Okay. We have minus 1 upon 2 cos 2x plus 1 plus 1 upon 6 cos cube. Okay. This answer is in the form of cos cube. So we can convert this cos 3 theta in the form of cos cube theta. Although this is our answer, and we can change into cos cube also. 2x plus 1, 1 upon 24. The formula of cos cube, cos 3 theta is, we can write cos 3 into 2x plus 1 dx, 1x, 2x plus 1 plus c equal to minus 3 upon 8 cos 2x plus 1 plus 1 by 24 cos 3 theta will be 4 cos cube 2x plus 1 minus 3 cos 2x plus 1 plus c. So it will be minus 3 upon 8 cos 2x plus 1 plus 1 upon 24. Now I can take them outside. So it here will be plus 1 upon 6. We'll cancel from 4 to 24 by 6 times. It will be cos cube 2x plus 1 minus 1 upon 8 cos 2x plus 1 plus c. Now if I will add these two function, so it will be minus 4 upon 8. We can write 1 upon 2 cos 2x plus 1 plus 1 upon 6 cos cube 2x plus 1 plus c. And this is also our answer. So it was plus 1 upon 6, fourth number. Okay, so it is fine now. Now we have fifth number. Okay, here we can apply this formula, sine 2x equal to 2 sine x into cos x. But for that we need 8 here inside, so that we can apply this formula. So what we'll do, we'll multiply 1 by 8 inside and 8 outside and 18 inside. So it will be sine cube x into cos cube x dx. So I can write 1 upon 8 into 2 sine x into cos x cube dx. So now we'll have 1 upon 8. 2 sine x into cos will be sine 2x cube dx. 1 upon 8 sine cube 2x dx. Now I think this is the same question, and now we can convert sine cube x by this trigonometric identity. Sine 3 theta equal to 3 sine theta minus 4 sine cube theta. So implies 4 sine cube theta will be 3 sine theta minus sine 3 theta. Implies sine cube theta will be 3 sine theta minus sine 3 theta upon 4. But here we have sine cube 2x. So what we can do? We can write sine cube 2 theta equal to 3 sine 2 theta minus sine 6 theta upon 4. So we can replace these trigonometric identities with 3 sine 2 theta minus sine 6 theta by 4, and we can easily integrate sine 2 theta and sine 6 theta. So you can proceed from here. Now we have question. This is 6th number. Okay. Integration sine x into sine 2x sine 3x. Here we can apply as we had done in the terms of cos x into cos 2x, and when cos 6x question was there. We'll apply this formula 2 sine a into sine b. 2 sine a into sine b is cos a minus b minus cos a plus b formula. So here I will write 1 by 2 outside. I will take 2 inside also. 2 sine x into sine 2x sine 3x. So 2 sine a into sine b will be cos x minus 2x minus cos x plus 2x sine 3x dx. And we know that cos x minus 2x will be cos minus x, and we know cos minus theta is cos theta. So I'm directly writing cos x. Reason we can give here, cos minus theta equal to cos theta minus cos 3x I can write into sine 3x dx. So now we have integration cos x into sine 3x minus cos 3x into sine 3x dx. So here we'll have integration. If you multiply 1 by 2 outside, I will take 2 inside also to use the formula of 2 cos a sine b to sine 3x dx minus 1 by 2 into, again I will multiply 1 by 2 outside and I will take 2 inside. So it will be cos 3x into sine 3x. Here we can apply the both formula 2 cos a sine b again, and also here theta is same, you can see. So once theta is same, we can directly apply 2 sine theta into cos theta also formula, sine 2 theta. So it will be 1 by 4. The formula of 2 cos a sine b will be sine a plus b minus sine a minus b. So here I can write dx minus 1 upon 4. 2 sine theta into cos theta will be sine 2 theta, so sine 6x dx. So 1 upon 4 integration sine 4x dx minus 1 upon 4 x minus 3x will be minus 2x, and sine minus 2x will be minus sine 2x dx, minus 1 upon 4 integration sine 6x dx. Here we'll have now integration of sine 4x is there. So we'll multiply minus 1 inside and minus 1 outside and minus 1 inside. So integration of minus sine 4x will be cos 4x, and we'll have to divide 4 in denominator also because 4 is there in multiplication. Minus 1 upon 4, and integration of minus sine 2x will be cos 2x upon 2, plus I will take here minus I'll put, so it will be plus 1 upon 4 integration of minus sine 6x will be cos 6x upon 6 plus C answer. We can simplify it more. We can write minus 1 upon 16 cos 4x minus 1 upon 8 cos 2x plus 1 upon 24 cos 6x plus C answer. So it was 6th number. So answer we have 1 by 24 cos 6x minus 1 by 4 cos 4x cos 2x. So 24, 16 and 8. 24, 16 and 8. Okay, minus sign with cos 4x. Okay, and minus sign with cos 2x. So it is right. We can take 1 by 4 common also. Even if you don't take, there is no problem. This is also right. So now we have 7th number. It is integration of sine 4x into sine 8x. So what we'll do, we'll multiply 1 by 2 outside and we will take 2 inside to use the formula of 2 sine A into sine B. Formula of 2 sine A into sine B is cos A minus B, cos A minus B minus cos A plus B. So once you will use this formula, you can break this product in the form of simpler form. And you now easily integrate these two things by separating into two integration. So it will be cos minus 4x, cos minus 4x will be cos 4x only. So dx minus 1 by 2 integration of cos 12x. And you can easily integrate cos 12x and cos 4x by method of inspection. So now we are moving on to next question. Eighth number is, this is 8th number, and here we'll directly use the formula of identity 1 minus cos 2 theta equal to 2 sin square x and 1 plus cos 2 theta equal to 2 cos square x. But here we have 2 theta, but in integration it is cos x. So what we'll do, we'll convert this formula in the form of cos x. So I'll write 1 minus cos 2 into x upon 2. So it is cos x only because 2 will get cancelled. So it will be 2 sin square x upon 2. And it will be 1 plus cos 2 into x upon 2 will be again cos x only. So it will be 2 cos square. Theta will be x upon 2. So we can use this formula. It will be 2 sin square x upon 2, 2 cos square x upon 2 dx. I'll cancel this 2 by and 2. So it will be 10 square x upon 2. So now we'll be using this geometric identity, sec square x minus 10 square x equal to 1. Why we are using this geometric identities? Because we know integration of this thing and we know the integration of constant, but we don't know integration of 10 square x. That's why I'm replacing 10 square x with sec square x and 1. So it will be sec square x upon 2 minus 1 dx. So we'll separate this function into two integration. Sec square x upon 2 dx minus dx. Integration of sec square will be 10 because the differentiation of 10 is sec square x. So it will be 10x. Okay, 10x will be answer. And then 1 by 2 in multiplication. So we'll divide by 1 by 2 minus 1 minus x plus c. So we'll get 210 x upon 2 minus x plus c is our answer. So this was 8th number. Answer is 210x by 2 minus x plus c. Okay, it's good. So now we are moving on to 9th number. So here we'll be using trigonometric identities cos 2 theta equal to cos square theta minus sin square theta. But here we have cos theta only. So what we'll write? Cos 2 into theta upon 2 equal to cos square theta upon 2 minus sin square theta upon 2. So now we'll have cos square theta upon 2 minus sin square theta upon 2. And we know that the formula related to this trigonometric function 1 plus cos 2 theta equal to 2 cos square x upon 2. 2 cos square x upon 2. So 1 plus cos 2 theta will be 2 cos square x upon 2. Cos square upon 2 minus sin square x upon 2. So now we'll have cos square x upon 2 by 2 cos square x upon 2 dx minus 1 by 2 I'll send outside. It will be sin square x upon 2 by cos square x upon 2 dx. We can cancel cos square. I will send 2 outside. So it will be dx minus 1 by 2 and this will become 10 square x upon 2. We can easily integrate this to x. It is x to the power 0. And to integrate this function, we can use this trigonometric identities. Sec square x minus 10 square theta equal to 1. So I'm leaving this to you. You can proceed from here. Now this is 10th number question. To integrate this type of function whenever power is 4, we'll always use this in trigonometric identities for sin to the power 4x and cos to the power 4x. For cos to the power 4x, we will use 1 plus cos 2 theta equal to 2 cos square x. I'm writing here 4 cos to the power 4x and 1 minus cos 2 theta 2 sin square x. For that, we'll make sin square x ka whole square. Now I can easily replace sin square x by 1 plus cos 2 theta. 1 plus cos 2x upon 2. I'll send 1 by 4 outside. So I'll have 1 plus cos square 2x cos square 2x 1 a square plus b square plus 2 cos 2x. So now we'll separate this 3 function. So I'll get 1 by 4 dx plus 1 by 4 integration cos square 2x dx plus 1 by 4 I'll take 2 outside integration cos 2x dx. You can integrate this function easily and this also. So, and to integrate this thing, I'm taking this is 1, 2 and third. So 1 and third you can integrate easily. To integrate second, what we can do? 1 by 4 cos square 2x dx. Again we can use the formula 1 plus cos 2 theta equal to Just be careful with theta, because here 2x is there with cos square, not with theta, not with cos. So what we'll do, cos square theta we can write 1 plus cos 2 theta upon 2. So here cos square 2x is there, so I'll write cos square 2 theta equal to 1 plus cos. Now theta has become 2 theta. So it will be cos 4 theta upon 2. So you can do 1 by 4 into integration 1 plus cos 4x upon 2. So it will be 1 upon 8 integration of dx plus 1 upon 8 cos 4x. Integration of 1 by 8, it will be 1 by 8 into x plus 1 by 8 into integration of cos 4x will be sin 4x, because the differentiation of sin is cos x. 4 was in multiplication with x, so it will go in division, plus, and you can put the value of this second into our main equation over here. So you'll get your answer. Now 11th number we have cos to the power 4 2x. So here we'll apply 1 plus cos 2 theta. 2 cos square theta. But here we have cos square 2x. So I'll have to make here theta also as cos 2 theta. At first, what I will do, cos square 2x square. So it will be now cos square theta is equal to 1 plus cos 2 theta upon 2. So I can write cos implies cos square 2 theta equal to 1 plus cos 4 theta upon 2. So I'll replace cos square 2x by 1 plus cos 4x upon 2 dx. And again, now I'll expand this with the formula of a plus b ka whole square. I'm sending 1 by 4 outside and I'm expanding this function. So it will be 1 plus cos square 4x plus 2 cos 4x. So now again here we'll have 3 integration dx plus 1 by 4 cos square 4x cos square 4x dx plus 2 upon 4 integration cos 4x dx. Again we can integrate this easily, and this also. This is third and this is second. To integrate second, again we'll use the formula cos square 4x dx, and this theoretic identity we'll be using 1 plus cos 2 theta equal to 2 cos square theta. So cos square theta will be 1 plus cos 2 theta upon 2. So 1 by 4 integration of cos square 4x will be, here my theta has become now 4x, so it will be cos 8 theta. So I'll write 1 plus cos 8x upon 2 dx. Now you can integrate this easily and you can put into second to get your required answer. And this is 12th number question. Here we can break this thing into 1 plus cos 2 theta identity. 1 plus cos 2 theta equal to 2 cos square x. 2 cos square x. Or we can use, okay, this thing also we can use. We can use the formula of a square minus b square, a plus b into a minus b. To use this, we'll be using this theoretic identities. Sin square x plus cos square x equal to 1. And we'll replace sin square x with 1 minus cos square x. In the formula of a square minus b square, I can write 1 square, 1 as 1 square. There will be no problem. So a square minus b square is a plus b into a minus b. So I'll write 1 minus cos x into 1 plus cos x by 1 plus cos x. I'll cancel them. So now we'll have integration dx minus integration cos x dx. So it will be x minus sin x plus c as answer. This is 12th number, and answer is okay x minus sin x plus c. Okay, it's good. So now we can move. We can apply some other trigonometric identities also. There is no problem. You will get answer same. I think we can break this into the form of 1 plus cos 2 theta h 2 cos square x upon 2. And then we can also break sin x in the form of 2 sin x upon 2 into cos x upon 2. So this is second method we can try. This is second method we can try. Sin x is 2 sin x upon 2 into cos x upon 2. So its square is there. So it will be 4 sin square x upon 2 into cos x upon 2. So now we'll have and 2 cos square x upon 2 dx. So we can cancel 2, simplify by 2 times. We'll send 2 outside and we can cancel cos square cos square. It will be sin square x upon 2 dx. Now we can easily integrate this thing with the formula of 1 minus cos 2 theta equal to 2 sin square x. And we'll have to set this theta as x by 2. So this will give you required answer again. This is our 13th number. Here we'll be using trigonometric identities 1 plus cos 2 theta equal to 2 cos square theta. So cos 2 theta will be 2 cos square theta minus 1. That is 2 cos square x minus 1 minus 2 cos square a minus 1 cos x minus cos a dx. So it will be 2 cos square x minus 1 minus 2 cos square a plus 1 cos x minus cos a dx. So we can cancel this minus 1 and plus 1, and we can take 2 common, 2 outside. So it will be cos square x minus cos square a by cos x minus cos a. Here cos a is constant, okay, and x is variable. So but right now I'll be using a square minus b square equal to a plus b into a minus b. So 2 into we'll get cos x minus cos a into cos x plus a dx. Cos x minus cos a. So now I can cancel this same term from numerator and denominator. So now we'll have 2 into cos x plus cos a dx. I'll have 2 into integration cos x dx plus 2 into integration cos a dx. Integration of cos x will be again sin x plus this cos a is constant. So I'll write 2 cos a into x plus c as our answer. We can check answer. This is 12th number. Okay, this is 13th number. 2 sin x plus x cos alpha. That is a we can take. Okay, 2 sin x plus x cos a. Cos a. So we can take 2 common. Okay, 2 sin x plus cos a x cos x cos a plus c answer. Okay, now we have this 14th number. The main thing is with this type of question, we need to see, observe on this thing. Whenever you watch this type of thing, try to apply. It is something like sin x into cos x, 2. So it is in the form of 2 into a into b. And what is a and b? It is cos square x plus sin square x plus 2 sin x into cos x. Now you can easily set the formula of a plus b ka whole square. So we are going to try that thing. So now we'll have cos x minus sin x. Here we can write at the place of 1. I told you in starting only, we'll replace 1 with sin square x plus cos square x plus 2 sin x into cos x. We are using sin 2x equal to 2 sin x into cos x, and we are using 1 equal to sin square x plus cos square x. So now we'll have cos x minus sin x is equal to sin x plus cos x square. That is a plus b ka whole square equal to a square plus b square plus 2ab dx. And if we try to differentiate this function, the differentiation of sin x will be cos x, and cos x differentiation will be minus sin x. So now we can use substitution method. Let z equal to sin x plus cos x. So dz upon dx will be cos x minus sin x dx. So now I will replace cos x minus sin x into dx by dz. And we have assumed that z equal to sin x plus cos x square, cos x. So it will be z square, and the integration of it will be z to the power minus 1 in division minus 1 will put plus c, and the value of z is sin x plus cos x plus c is our answer. We can check this was our 14th number. Okay, minus 1 by cos x plus sin x, it is good. Moving on to next question. So this is our 15th number. Here we'll be using tan square x sec square x minus tan square x equal to 1. So what we can do, we can write tan 2x into tan square 2x into sec 2x into dx. So now we'll have the formula that we are using, this thing, tan square x equal to sec square x minus 1. Okay, so we'll have tan 2x into tan square x will be sec square 2x minus 1. So this will be sec 2x into dx equal to, now we can write sec square 2x, it is sec cube actually, tan 2x dx minus, I'm separating also, okay, it will be tan 2x into sec 2x dx. Here we'll be using substitution method for this first part, and the second part is easily we can integrate because the differentiation of sec x is sec x into tan x. So what we can take, if I take 10x equal to z, we'll get sec square x is differentiation. But there will be no benefit because again one sec will be left. So what we can take? We can take let z equal to sec x. So differentiation of sec x will be sec x into tan 2x. So now we'll have z equal to sec 2x is there. So we can write z square into, and I will replace sec 2x into tan 2x dx by dz. So now, and the integration of this thing will be sec 2x upon 2 plus c. Integration of z square will be z cube upon 3, and we know z equal to sec 2x. So it will be sec 2x to the power 3 upon 3 minus sec 2x upon 2 plus c as our answer. So this was our 15th number. Okay. So we have 1 by 6 sec cube 2x minus 1 by 2 sec 2x. Okay. So minus 1 by 2 it's fine. Or here 1 by 6 is there. Okay. This much it is fine. Sec cube. This is okay. So okay. Okay. The differentiation will be sec 2x into 10x, tan 2x. But again, 2 will come in. 2 will come outside also. It will be dx because 2 is in multiplication. So implies we'll replace dz upon 2 by sec 2x into tan 2x dx. So we'll have 1 upon 2 outside also. So it will be 1 upon 6 sec 2x whole cube minus 1 by 2 sec 2x plus c answer. So we have solved this 15 number. Now we are moving on to 16 number. We have integration of 10 to the power 4x dx. So again we'll apply here sec square x minus tan square x equal to 1. We can apply this also. Okay. So now we have tan square x into tan square x into dx. So we can write tan square x equal to implies sec square x minus 1. Basically, whenever tan square is there in integration or anything related to 10 to even power or even odd power, try to just see this form, this identity once. You might be able to solve it. So we are using the same identity. So tan square x will be sec square x minus 1. We'll get sec square x into tan square x minus tan square x dx. So I will separate this expression into two integration. Sec square x into tan square x dx minus integration tan square x dx. This second part we can easily integrate. So for first part we can use substitution method. Let z equal to tan x. Why we are using this substitution method? Because we know differentiation of tan x is sec square x, and we'll substitute sec square dx by dz. So dz equal to sec square x into dx. We'll get dz. We are replacing this thing by dz and tan square x from z square. So we'll get z cube upon 3. So tan x whole cube upon 3. And whatever you will get by solving this second part, this will give you required answer. 17 number we have sin cube x plus cos cube x by sin square x into cos square x. See, one thing we can apply here in denominator, we have a hint. 2 sin, if it is 4 sin square x into cos square x, we can simplify it to get sin square 2x. But there will be no benefit. There can be any benefit. Sin square, then it will be in theta will be in terms of sin 2x. So there will be no benefit even in solving. So what we can do in this type of question, we'll try to separate these addition terms into two fraction. Like this we can do integration sin cube x upon sin square x into cos square x plus cos cube x upon sin square x into cos square x dx. Now we can cancel this sin square from numerator and denominator both. We'll get sin x upon cos square x dx plus, we'll cancel cos square from numerator and denominator both. We'll get cos x upon sin square x dx. So we'll get sec x into tan x dx plus cot x into cosec x. So these two we can easily integrate because the differentiation of sec x is sec x into tan x. So sec x and the differentiation of cosec x is minus cosec x into cot x. So it will be minus here we can multiply by minus inside and outside also. So it will get, so integration of this thing will be cosec x plus c as our answer. This was 18th number. Yes, okay, it is 17th number. 17th number answer is sec x minus cosec x plus c. Okay, it is right. Now we have 18th number. We can apply here again. This sin square term is there. So if we use this identity, we can see what we will get. 1 minus cos 2 theta equal to 2 sin square x. So once we are using this identity, we will get 1 minus cos 2x. And we will be able to cancel cos 2x. One is in plus cos 2x and one is in minus. So we'll get 1 upon cos square x. Then we can easily integrate. So yes, cos 2x, and we are replacing 2 sin square x by 1 minus cos 2x cos square x dx. So here we will get sec square x into dx. Integration of sec square will be 10x plus c. So answer is 10x plus c. Okay, it is good. We are moving on to 19th number. 19th number is 1 upon sin x into cos cube x. If I send cos square as sec square x, but we don't have in denominator as 10x. So one more thing we can do. If I divide, there will be benefit if I do like this. Integration, if I divide by cos in numerator and denominator both, I will get 10x, and this will become sec x. So sec x, okay, into 1 dx upon cos cube x. So what I have done, by dividing cos x in numerator and denominator both. So we'll get, why I did that? I thought to make this as 10x, and then the differentiation of 10x is sec square x. So this was my main thing. That's why I moved ahead like this. So it is 10x. It will be sec to the power 4x into dx. So now what we can do, we can use substitution method from here. let z equal to 10x. So dz will be sec square x dx. Okay. So if I want to substitute, so it will become sec square x upon, this will be z. Okay. And we are substituting this by dz. So it will be dz. But this integration is in terms of z. So I'll replace sec square by z. Sec square minus 10 square theta equal to 1. So I'll write sec square equal to 1 plus 10 square x upon z dz. So it will be 1 plus, and we'll replace 10x by z. So it will be z square. So now I can solve this integration easily. I'll get integration 1 upon z plus z dz. So integration 1 upon z dz plus integration z dz. So we'll get integration of 1 upon z is log z plus z square upon 2 plus c. This should be our answer. But we have to replace z by x also in terms of x. Z is 10x. Log 10x plus 10x square upon 2. Here we can use some other method also, some other trigonometric identities. I've told you here I can try. I can replace 1 by sin square x plus cos square x. We can try. We'll see whether it is like we get success or not in solving. Why I'm trying this? Because once I will write sin square plus cos square x, then I can separate. After separating, it will be easy to cancel them. So here I am writing sin square x plus cos square x upon sin x into cos cube x dx equal to integration sin square x into sin x into cos cube x dx plus cos square x into sin x into cos cube x dx. So it will be sin x, I can cancel them. It will be 1 upon sin x into cos cube x dx plus, I can cancel cos square, it will be 1 by sin x into cos x. Here you can, this is second part, you can easily integrate this by using the formula of sin 2x. This formula sin 2x to sin x into cos x. And then 1 by sin 2x will be cosec 2x. You can easily integrate. And here you can use substitution method. Let z equal to cos x, and you can proceed in this way. Differentiation of this will be sin x dx. You can replace sin x dx by dz, and it will become 1 upon z cube. So you can solve this way, in this way. So next question we have 20th number. Okay. So here what we can do, we can apply cos 2 theta equal to cos square x minus sin square x. Will there be any benefit of it? We can try that. Cos 2 theta equal to cos square x minus sin square x. It will be cos x plus sin x into cos x plus sin x, because square was there. So I can cancel cos x plus sin x, cos x plus sin x. Or we could have simplified this thing into, we could have cancelled sin square plus cos square equal to 1. But let's see what happened to this method. Cos x plus sin x upon cos x plus sin x. Okay, here it will be minus sin x. So we can cancel them. And the differentiation of cos x is minus sin x, and the differentiation of sin x is cos x. Okay, we can solve this question by this method also. You can try n number of trigonometric identities, there is no problem, but answer will have to be same at the last. We can substitute let z equal to cos x plus sin x. So differentiation of this will be, I'm writing, there is no problem even if I write sin at the first, sin x plus cos x. So it will be cos x minus sin x dx. So equal to, we can replace this whole term by dz. So dz upon z, it will be log z plus c, and the value of z is log cos x plus sin x plus c, answer. So we can see this was our 20th number. So we have log cos x plus sin x, it is right. So we are moving on to 21st number. So this is 21st number. This integration is in form of inverse trigonometric function. So although we can use some identity of inverse trigonometric also, but right now I'll be using substitution method and trigonometric function only. So I'm using substitution method. I'm taking z, let z equal to cos x. So differentiation of z with respect to x will be minus sin x into dx. So implies dx will be replaced by minus dz upon sin x. But then I have to convert this sin x also because the integration will in the form of z. So since cos x equal to z, so sin x will be under root 1 minus z square equal to integration sin inverse cos x dx will be sin inverse cos will be z, okay, and dx will be minus dz upon sin x. And now we can replace sin x by under root 1 minus z square. So it will be minus 1 by under root 1 minus z square dz. One thing we can guess here, the differentiation of sin inverse z is 1 upon 1 minus z square. So we can substitute let t equal to sin inverse z. So differentiation of dt with respect to dz will be 1 upon under root 1 minus z square z square. So dt will be 1 upon under root 1 minus z square dz. I will replace this whole term with dt. Implies sin inverse, okay, and I will replace sin inverse z with t. So it will be t into minus, I'm sending outside, it will be dt. It will be minus t square upon 2 plus c as our answer. But for t is sin inverse z, it will be minus sin inverse z upon 2 square plus c. And the value of sin z is cos x minus sin inverse cos x square by 2 plus c as our answer. We can check. This was our 20th number, 21st number. Okay, so the answer is given in the form of pi x upon 2 minus x square by 2 plus c. Okay. This is also right. This answer is also right. If we want to simplify more, we can use from here the property of inverse trigonometric function. Yes, the property of inverse trigonometric function is sin inverse x plus cos inverse x equal to pi by 2. So if I want to replace this with cos in the form of cos inverse x, I will get sin inverse cos x plus cos inverse cos x equal to pi by 2. This implies sin inverse cos x is equal to pi by 2 minus cos inverse cos x. And we know that cos inverse cos x is nothing but x. So pi by 2 minus x. So I will have answer h from your equation 1. We can write minus, we can replace sin inverse cos x by pi by 2 minus x square by 2 plus c. It will be minus 1 by 2 into 1 by 2 into pi square a square plus b square minus 2 into pi by 2 into x into 1 by 2 is there in multiplication plus c. So it will be minus pi square upon 8 minus x square upon 2. This 2 and 2 will get cancelled. So it will be plus pi by 2 into x plus c as our answer. We can check now answer. Minus pi square upon 8. Minus pi square upon 8. Okay. Minus x square by 2 plus c. Okay. Pi x by 2 minus x square 2. Pi x by 2 minus x square by 2. Okay. Plus c. And this is a constant only. So we can replace this by some new constant. I can write this equal to pi by 2x minus x square by 2 plus some k constant, where k is equal to minus pi square upon 8 plus c. So this is our answer. Now this is 22nd number. Okay. Whenever you get some question like this, x minus a and x minus b, try to use some formula like this. Try to set some formula. X minus a minus, I can set x minus b minus, okay, wait. I can set x minus a minus x minus b. Once I'll open this two, x will get cancelled. It will be minus plus. So b minus a form. So I can multiply something b minus a here. But cos, there will be no benefit if I write like this only. So I need to put some sine or cos. So I'm putting sine because sine will give in alternate form sine into cos and cos into sine. So one term I will be able to cancel. So I'm writing sine. So here also sine. Cos x minus a into cos x minus b dx. So now I will have sine b minus a. This is this expression is in the form of sine a minus b equal to sine a into cos b minus cos a into sine b. So I'll write sine a into cos b minus cos a into sine b dx equal to 1 by sine b minus a. Now I can separate this into two fractions. It will be sine x minus a cos x minus b by cos x minus a. I'll be able to cancel each term, cos one term from each expression. X minus b, this is cos, minus cos x minus a into sine x minus b. Cos x minus a into cos x minus b. If I had taken in terms of cos, I would have taken here cos. So it would have been cos A minus B. So the formula of cos A minus B is cos A into cos B plus sin A into sin B. I could not have cancelled one term from second part. That's why I've taken sin here. Now I can cancel cos here, and here I can cancel cos x minus A. So I'll get 1 by sin B minus A integration. It is tan x minus A dx minus 1 by sin B minus A integration tan x minus B. Integration of tan x is log sec x. 1 by sin B minus A log sec x minus A minus 1 by sin B minus A log sec x minus B. So now I can take common 1 by sin B minus A, and I can use the formula of log. So we'll get log A minus log B. It will give me log A upon B sec x minus B. So now we can check our answer. It was 22nd. Okay. Okay, answer is given in terms of sin A minus B. We can change. So once I'll write A minus B, I'll get one negative sin A minus B. And it was in terms of cos, so we can write cos x minus B cos x minus A plus C here also. So but then minus is there, so it will go into negative power of this expression. So I'll get 1 by sin x A minus B log cos x minus A upon cos x minus B plus C as our answer. Here I've used property log A to the power B equal to B log A base A. Now we have 23rd number. Again, we can use here the formula cos 2 theta equal to cos square x minus sin square x. We can try this. Okay. So we have cos 2x as cos square x minus sin square x. So it will be minus cos 2x. Okay. In denominator, we have sin square x into cos square x. So I need 4 also in denominator. I'll write 4 in multiplication. In outside, I'll put 4 sin x into cos x dx. So I can write 4 into, I can take minus outside, it is cos 2x upon 2 sin x into cos x square dx. So I will get minus 4 into cos 2x upon sin square 2x dx. So it will be minus 4 into cos upon sin, it will be cot 2x into, and then one will be sin 2x. So it will be cosec 2x dx. And when we know that the differentiation of cosec x is cosec x into cot x with negative sign. So I can write plus 4 into, I'm taking this minus inside only. So it will be cosec 2x. But 2 is there in multiplication. So now it will go in division also. Plus C as our answer. So it will be 2 cosec 2x plus C as our answer. So now we can see answer of 22nd number. Okay, this is 23rd number. It is A. And what is A option? It is multiple choice question. So A is tan x plus cot x plus C. So what we can do from here? we can try a different method also, but we can expand this also to get this our answer. We can write 10x plus 1 by 10x, or we can check for particular value. We can take x equal to some theta 30 degree, and we can check that the answer of these two will be equal. So by this way, we can solve multiple choice question, even if answer is different. Like both answer is same, value will be value. Both answer expression is different, but value will be same only. So here we are solving. We will get 10 square x plus 1 upon 10x. At sec square minus 10 square equal to 1. So 10 square plus 1 will be sec square x upon 10x. So here we'll get 1 upon cos square x. This sin x will give sin x upon cos x. So it will be cos will get cancelled. It will be cos x upon sin x. Cos x into sin x in denominator. So again we'll multiply 2 in numerator, 2 in denominator. So we'll get 2 into sin 2x. So we'll get 2 into cosec 2x. Okay, yes, these two things are same. So this is our answer. Otherwise, we could have applied one more method into this question. Second method we could have applied. Second method. We could have separated these two terms, the expression, like this sin square x upon. We could have cancelled them easily because in denominator also square is there of sin and cos, and in numerator also dx minus cos square x upon sin square x into cos square x dx. So we can cancel this two term. We'll get sec square x dx minus cos got cancelled, so it will be cosec square x dx. I can write plus here. I'll take minus inside. So integration of sec square x will be 10x, and differentiation of cot x is minus cos square x. So integration of minus cosec square x will be cot x. So this was our answer. This is so easy by this method. Both are right. So now we are moving on to 25th number. 24th number. Okay. So now we have this integration. We'll try to use here substitution method, because if you observe carefully, if you substitute let z equal to e to the power x into x, because the differentiation of this thing with respect to x, it is giving me x plus x is differentiation with power x. Here I can take e power x is common, I will get 1 plus x. Okay, and this is already in numerator. So now I can substitute this. So dz upon dx equal to e to the power x into 1 plus x into e to the power x. So I'll write e to the power x into 1 plus x. It will imply dz equal to e to the power x into 1 plus x dx. So now we can write dz upon, I'll replace e power x into x by z. So it will be cos squared z. So now I can write cos squared z will become sec square z. And we know that differentiation of tan z is sec squared z. So by method of inspection, integration of sec squared z will be tan z. And now I'll have to replace the value of z in terms of x. So z was equal to e to the power x into x. Okay, I can write tan e to the power x into x as our plus c as our answer. So we can check answer. So option 24th number is multiple choice question. Answer is B. Okay, 10x into e power x. Okay, it is right. Okay, so we have solved all this 24th question. We'll try to solve even next exercise in coming week. And after solving these all exercise, we'll try to cover all the types of integration. So please get connected with my channel, like and subscribe Fun with Learning to see all the coming videos in next week. So thank you.